The topic today is longitudes and latitudes, and the question reads: a jet on a rescue mission left town A 35 degrees south 50 degrees east to town B 45 degrees north 15 degrees east, and then to town C 45 degrees north 45 degrees west. If the radius of the earth is 6,370 kilometers and pi is 22/7, find part A, the distance from A to C via B in nautical miles, correct to 4 significant figures. B, the distance in kilometers from A to B to the nearest kilometer. C, the jet flew at 840 kilometers per hour from A to C. If the jet left town A at 8:15 a.m., what time will it arrive at town C in local time? So straight to part A, we will first of all locate the positions of town A, B, and C. So on the globe, we have got the prime meridian set at 0 degrees. We also have the equator set at 0 degrees. So these are the reference points. Then town A lies on latitude 35 degrees south. So we have 35 degrees south, and on longitude 15 degrees east. So 15 degrees east. So this is east of the prime meridian, 15 degrees east of the prime meridian and 35 degrees south of the equator. So where the two meet, that is the position of A. Now for B, B lies on latitude 45 degrees north, so the north of equator, so that is up here, 45 degrees north, and on longitude 15 degrees east, so the same longitude 15 degrees east, so where they meet, that is the position of B. And then the plane also flew to town C, which is on latitude 45 degrees north, still this latitude here, and 45 degrees west of the prime meridian. So to the west of the prime meridian, so this is longitude 45 degrees west. So where the latitude and the longitude meet, that is the position of C. So the plane moved from A to B and then from B to C. So the question we are asked is to determine the distance from A to C via B in nautical miles. And for us to get the distance in nautical miles, so AB, the distance in nautical miles is given by theta times 60. Remember, we're moving along a great circle. So all longitudes are great circles, and therefore we use the formula theta times 60. Basically, this comes from the fact that 1 degree is equal to 60 nautical miles. Therefore, theta degrees will be equivalent to what? So that leads to this particular formula here. That implies that theta is equal to the angle difference. So the angle difference between the latitudes, remember when you're moving from point A to B, it is the latitudes that are changing. So we are moving from latitude 35 degrees south to latitude 45 degrees north. So from 35 degrees south of the equator to the equator, that is 35, and then from the equator to latitude 45, that is 45 degrees. So the angle difference will be the sum between 35 and 45. So we're going to have 35 plus 45 as the angle difference, and that is 80 degrees. So that simply implies that AB is equal to angle 80, so substituting here, times 60, and that is 4,800 nautical miles. Again, we need to move from B to C. Remember, we're moving from A to C via B, so we've moved from A to B, B to C. So BC is now a distance along a latitude, that is a small circle, and this we are going to work out by simply having the formula theta 60 cosine of alpha, and for this case alpha is the latitude, so remember that theta for this case will be the longitudinal difference. You are moving from longitude 15 degrees east to longitude 45 degrees west, so remember here the longitudes are changing, so get the angle difference from 15 degrees east longitude up to the prime meridian, that is 15, and then from the prime meridian to longitude 45 degrees west we have 45, so the total angle is the sum 45 plus 15, so that should give us 60. And we also know that alpha is the latitude, so we are moving along latitude 45 degrees north, so alpha is 45 degrees, so that implies that BC will now be obtained by theta, which you've already obtained as 60, so 60 times 60 times cosine of alpha, and alpha is 45. So this should give us 2,545.5844. Therefore, the total distance AC is obtained by simply adding AB to BC. So we have AB we already have as 4,800, and BC we have as 2,545.5844, and that finally should give us 7345.5844, which is approximately 7,346, and of course that is in nautical miles. So we have our answer expressed to 4 significant figures as required in the question. So for part B, we need the distance in kilometers from A to B to the nearest kilometer. We need to recall that distance along a great circle is usually given as theta over 360 times 2 pi r, where r is the radius of the earth, and so that is the first one. And distance along a small circle, that is on the latitudes, is given by theta over 360 times 2 pi r, where r is the radius of the small circle. But you also need to know that r is given as r cosine of alpha, which implies that the distance along a small circle is given by theta over 360 times 2 pi r, but r is r cosine of alpha. So the distance in question here is the distance from A to B. When you move from A to B, you're moving along a great circle, that is a longitude. Therefore, we are going to use this formula here. So that means AB is equal to the angle difference theta. So we're going to get theta here, and theta is the angle difference between A and B. Fortunately, we had done it earlier on. The angle difference was 80. So between 35 degrees south and 45 degrees north, we have angle difference of 80. So here is 80 over 360 times 2 times 22 over 7, as we had been given in the question. Pi is 22 over 7 times 6,370. And this, when you work it out, is 8,897.777 recurring. And to the nearest kilometers, that is to the nearest whole number, we need to have it as 8,898 kilometers. Kilometers. But see, we are told that the jet flew at 840 kilometers per hour from A to C. If the jet left town A at 8:15 a.m., what time will it arrive at town C in local time? So we know that the distance AC, as we had seen earlier on here, is 7,345.5844. nautical miles, but 1 nautical mile is equal to 1.853 kilometers, which implies that AC in nautical miles is 7,345.5844 times 1.853, and that is 13,611.36789 kilometers. And the time taken to cover the distance is given by distance over the speed, and the distance is 13,611.36789 kilometers all over the speed, and the speed we are given as 840 kilometers per hour. So this should be 16.204 hours, which is also expressed as 16 hours, 12 minutes. And we can now get the time difference between A and C. So A and C lie on different longitudes. That means that they have different local times. So A lies on longitude 15 degrees east and C lies on longitude 45 degrees west. And the angle difference between the two longitudes would determine also the time difference. So the angle difference we had gotten as 15 plus 45. So theta is equal to 15 plus 45 degrees, and that is 60 degrees. But you also know that 15 degrees is equivalent to 1 hour. Therefore, that would imply that 60 degrees would be equivalent to 4 hours. So this is the time difference between A and C. But when the jet arrives at C, the time at A is as follows. So by the time the jet is arriving at C, remember the jet took 16 hours, 12 minutes. So as the jet moves, the time at A also keeps on changing. So the jet left town A at 8:15 a.m. and took 16 hours, 12 minutes for the entire journey. And that means by the time the jet arrives at C, the time at A is 12:27 a.m. the following day. Therefore, the time at C will be obtained as follows. So by the time the jet arrives at C, the time at A is 12:27 a.m. and at that particular time we know that the time difference will always remain to be 4 hours between the two towns. So if it is 12:27 a.m. the following day at town C, remember town C is to the west of town A. Town A therefore should be ahead in time. So if the time at town A is 12:27 a.m. the following day, then town C must be behind in time. So we're going to subtract. So we have 12:27 a.m. minus the 4 hours, and that should give us 8:27 p.m. But this is on the same day. So finally, the jet arrives at C at 8:27 p.m. the same day. So that is it for this question. I want to thank you for your patience until this time. Thank you for watching. See you in the next video.